For centuries, we categorized greed as a moral failing. We treat it as a sin, a psychological defect, or character flaw infecting the human mind. In high-level economic theory, greed is stripped of its moral weight. It is viewed as a predictable, measurable variable used to model human behavior. Economics relies on a specific model of human behavior, known as Homo economicus. This is an idealized version of a person who processes every decision as a cold calculation, designed solely to maximize their own self-interest. The classical assumption is that millions of these self-interested calculations, working together, create an invisible hand that guides the economy to maximum efficiency. Yet our history is defined by market crashes and massive resource depletion. To understand why our systems keep breaking, we must stop looking for moral breakdowns and start looking at the equations governing our choices. Economic failure occurs when every actor executes mathematical logic with flawless precision. Economists measure this logic using game theory, a branch of mathematics that models how independent actors make decisions when their payouts depend on each other. The most famous model is the prisoner's dilemma. Two isolated individuals are brought into a scenario where they must make a single choice: cooperate with the other person or betray them. This matrix breaks down the exact numerical values of those choices. There are 4 possible outcomes based on how the two players act. Look at the top left quadrant. If both actors cooperate, they achieve the highest combined payout. Collectively, this is the optimal outcome for the system. But the math contains a trap. If you choose to betray and your partner cooperates, you get an even larger personal reward. If your partner decides to betray you, your only defense is to betray them back to minimize your personal risk. Mathematician John Nash formalized the reality of this matrix. He proved the existence of what we now call the Nash Equilibrium, a state where no player can improve their individual payout by changing their strategy alone, which naturally defaults everyone to the greedy choice. In a mathematically structured scenario without absolute trust, choosing mutual destruction is the only logically sound option available to the individual. That logic is dangerous in us between two people. Now apply it to a global economy of 8 billion individuals. This equilibrium logic scales into a phenomenon called the tragedy of the commons. It happens because every individual in a massive group faces the exact same betrayal incentive as the two prisoners. This diagram represents a shared system. The center is a finite, replenishable resource, like ocean fish stocks or available credit, surrounded by individual actors pulling from that pool. If one actor pulls more than their share, they gain an immediate competitive advantage. To avoid a catastrophic disadvantage, every other actor must follow suit, pulling as much as possible before the resource vanishes. The math of self-preservation demands that everyone accelerates their consumption until the central resource depletes to zero. Whether the shared resource is atmospheric carbon capacity, groundwater, or mortgage liquidity, individual optimization guarantees collective ruin. We saw this equation play out in real time during the 2008 financial crisis. Banks were operating within a shared pool of mortgage debt. The 2008 crash represented the underlying equations of the market reaching their logical conclusion. The financial market heavily rewarded selfish optimization. Firms that generated high-risk mortgages received enormous short-term payouts. Any firm that chose to limit their risk was penalized by the market and lost out to their competitors. Blaming economic devastation on a few bad actors ignores the mechanics of the crisis. When an economic structure rewards aggressive extraction, the system is mathematically geared toward collapse. If human self-interest is a fixed input, we cannot prevent collapse by asking people to act against their own benefit. Moral pleas do not stop algorithmic optimization. To change the final output, we must change the variables in the equation. Look at the matrix again. Regulations, carbon taxes, and financial penalties act as weights that subtract value from the betrayal quadrants. When the penalties for extraction are high enough, the Nash equilibrium shifts. Cooperation becomes the most mathematically profitable choice for the individual. As long as the system rewards individual extraction, the collective will suffer. To save the commons, we have to rewrite the math that governs it.